So I forgot to say this before we started, but it's important as prerequisites to know about the system design concepts we have talked about in this entire series. Stop looking at this diagram because you're not going to understand till we actually start discussing about it. And each of these concepts that we are going to discuss now can be broken down and gone deeper into. So all those concepts will require prior knowledge that is going to be given to you through the videos that I made earlier, and also of course through lots of links on the internet. So it's your choice. Just make sure that you have your basics and fundamentals clear before you actually jump into actually designing a system. Okay, let's start. Hi everyone, we are finally here. We are finally talking about Tinder, and we are talking about its architecture. So let's say you entered the interview room, you meet the interviewer and you sit down. So you're asked to design Tinder. Now, in my experience, I've seen that most candidates get really into the game. They start thinking about what services are they going to use, what kind of databases are they going to use. But my suggestion to you would be to take a step back and think of this system in a very logical, calm way. So if you have been inventing such a kind of an app, what's going to come up in your mind is, what kind of features will I provide this person? And with those features, what can happen is you can actually think about how your system evolves. Two approaches that you can have for this, for starting off with this, is to start with the ER diagram, which we are taught often enough in colleges, that think about how the data is going to be modeled, and then think about how your services are going to consume them. Finally, think about what the clients will be doing to actually call the services. So that kind of thinking is a little too constrained. It's also too abstract because you're thinking about how to model your data without thinking about what do your users need. The second approach is to go from the front to back. That is, think about what your users need as features. Think about how your services are going to actually be broken down so that you can fulfill these features, and then think about their individual data requirements per service. So in that way, your system is far more flexible. It's also a lot easier to start off with the system immediately with feature development, per feature development. So the features that we are picking up in Tinder are storing profiles, all right? So you won't just write this down, first of all. What you could say, what you could ask your interviewer is, so you're definitely going to be storing profiles, right? So that's an obvious question, but best to get it out of the way. In that profile, there are going to be images. That's really important for any dating site. So one thing to remember here is that images will be stored in the profile. A follow-up question can be, so how many images per user do you want? That could be 5. So I'll just note that down. 5 images per user. Is there something else we want to think about images? No. We can move to the next feature that might come up, which is how are we going to recommend matches? Yeah, I had to look into that. But if you think of this in a storyline, what happens is you go to any dating site, you make a profile, and that's how you're thinking about storing profiles. You start accepting or rejecting people based on your preferences. So that would be the recommendation system. That would be some sort of recommending matches. Yeah. In that case, what are the questions you can think of? How many active users do you have is a good question to ask. So number of active users. Is there something else you want to ask? Maybe are there certain countries where there's too much population stuff? But don't get into too much details. Again, if you're running behind too many questions per feature, that also shows that you're getting into too much detail per feature. So keep it fluffy, keep it flying in the air even now. Then you have the third feature, which is the best one, which is when you match with someone. So if you match with someone, you need to note that down, and you need to do something between the two people. So one of the things you want to do is you want to note down matches, in which case the number of active users is kind of enough. You can take a percentage of that as the number of matches you'll have per day. That's going to be an assumption. I'm going to assume that typical Indian match rates are going to come up here, which is for every swipe, you have a 0.1% of matching with someone. All right, so the number of matches you'll have per person is going to be 0.1%. So that's going to be number of active users into 10 raised to power minus 3 matches. And the fourth one is once you have matched with someone, of course, you need to chat with that person. So there's direct messaging, which will be a feature of Tinder once you guys match. All right. In direct messaging, what kind of questions should you ask? Well, we'll get to that. For now, we have 4 features. Avoid taking too many features because it's going to be an hour-long interview at most, and more often than not, you're going to be getting into the details that the interviewer wants you to get into anyways. You don't need to pull out more and more features just for the sake of showing that you can implement these. Okay, so start with 4 or 5 features. Let's start with storing profiles. So storing profiles, in fact, the previous video also talked about this, designing Instagram. There was a lot of jargon that a lot of you felt was there. Storing images has only one important question in it, all right? And that is, how are you going to store images? So there's going to be a lot of images. As you can see, number of active users are large. Per user, you have about 5 images, which is still a constant factor of the number of active users. And the question of how are you going to store these images is something which has been debated for a really long time in the whole technical field that we are in, computer science. And that is whether you want to store the images as a file or you want to store the images as a blob. Okay, so blob is a binary large object. And those of you who don't know about this, get back to your database classes because this is something which is taught in engineering. There's also another one which is CLOB, character large object, and that's entirely useless, so ignore that. We are going to be having the argument of file versus blob. So images typically are large in size, and you can't store it as a varchar or something. That's the reason why you have a binary large object, which is specifically for large objects in databases. Now, you might think that databases have definitely got a lot more to offer when it comes to specialized storage compared to files. But my argument is not really, because the only few extra guarantees that a database gives you are mutability. Okay, you can easily mutate the rows in that database, basically one data entry. The second one is transaction guarantees. So transaction guarantees. The third one is indexes. Okay, so indexes are mainly to improve your search capabilities, right? Let's start with mutability. Are you ever going to be changing the image? You could, yes, but why would you ever want to do that? Why not just create a separate file? Because an update to an image is not going to be just a few bits. So it's going to be the entire image, basically. Why not store that in a separate file and get rid of mutability, make it immutable? So this is an unnecessary feature that the database is giving us. The second thing is transaction properties. So transaction properties are again not required by an image because you're not going to be doing an atomic operation on the image. So you can get rid of this. There's another feature actually, I better note that down. So that will be the fourth feature which is required, and that is access control. So yeah, let's get to the third one again. Indexes. Indexes are good for searching. They allow your data to be sorted according to a particular field. Let us say you have a profile table in that the name can be indexed. So anyone who's searching for Gaurav will find that entry quickly because it binary searches on the name. So for a binary large object, that's useless because you're never going to be searching on the content of the file. That's going to be ones and zeros, right? So you can get rid of that. And finally, access control. This is very important. It's one of the arguments for databases using binary large objects, but I would say that you can get the same access control mechanisms using a file system, right? It is a little tedious maybe, but setting up a file system, a secure file system, is almost as tedious as setting up a secure database, so nearly equal. The good things about a file are that it's cheaper. That makes a big difference, storing files. The other things about files which are good are that they are they're built for this. They're built for, storing a file, and an image is a literal file. So that's one good thing, but it's a little abstract. Instead, they are also faster in a way because they are storing large objects separately. And you can do that in a database using something called vertical partitioning, where the profile ID is going to be over here and the image ID is going to be over here, and then you're going to store the image somewhere else. But if you're doing that, then why not store it on a file, which is not just cheaper, it's also less likely to do a select star nightmare. So if you do a select star on this table, so instead go for the file system. It's going to take care of that. I mean, you won't do a by mistake select star on the address and the ID. Okay, this is a little bit of a flimsy argument, but it's still, in practical real life systems, select star is used a lot. So it's one of the good things. The third thing is that these are static, so you can easily build a CDN over this, content delivery network. You can read up on this maybe in the description below. You can just read up on it in general. Content delivery network allows fast access. One argument for databases, which are going to be storing the files, I mean, at the end of the day, your database is going to be storing all your data. So it has to have some reference, some address to your file. And that is going to be the file URL. All right, and this will be stored in the database. So we are going to have an image ID of image URL and the profile ID per image stored by user with profile ID in location so and so. Where are you going to store this image, this file URL? It's going to be in a distributed file system, right? So your distributed file system is going to be handling requirement number 1. And that's how you argue for files versus blobs. Now, if your interviewer is really, really pushing you for blobs, you could take it. I mean, it's not going to really spoil your design. It's only that it's good to have these arguments with you when you're logically, talking about what would be better in an interview. But don't push too hard. If they say that blob is what I want, go for it. So taking this first option, let's start designing our system. The first thing to note here is that we have a client application on the mobile. A user actually clicks a button to send us a request. Okay, and over here we have our profile service. Now what does it need to do? It needs to register itself with our profile service. It needs to say, here's my username, here's my password, and the profile service then stores that in the database. Okay, of course, there's going to be multiple authentication mechanisms. There's going to be a password sent to the email, so there might be an email service which you're using here. But for the sake of brevity, I'm just going to assume that the profile service can send emails and can do those two-step authentication stuff. Okay, so once a user is stored in the database, the user then asks for something. It's probably going to be update profile because they're going to be adding their photos. So in update profile, with the username, how do you make sure that this is an authenticated request? The person who's claiming to update that profile is the person who that profile belongs to. There's multiple ways to do this. The monolithic service way goes that in the profile service, you're supposed to have authentication mechanisms, making sure that, yes, this update has come from the right user. So they'll send the username and password. And if it is authenticated, then a successful response goes back that, yes, there's been an update. Of course, there's multiple issues here. The first one being that username and password is a little too insecure. So instead, we can send a token, right? And these are all security mechanisms. If you mention token, you should be good. If your interviewer gets too deep into cryptography, then best of luck. But if you are sending a token to the profile service, it should be able to authenticate you and send back a response. Here's the problem. Today, there's a profile service which is actually authenticating and sending you back responses. If there's a new service coming up tomorrow, which doesn't have information about tokens and usernames, then that service is going to be requiring to talk to the profile service every time. And that logic is going to be duplicated in the third service which is going to come up. It needs to authenticate the user. So every time a user sends a request, there's going to be a lot of duplicated code which is going to be run. So one of the things you can do here is to a standard service which most places use is to use a gateway. And the clients always talk to the gateway. No one talks to the clients except the gateway. So this is the gateway service. All right, and the gateway does one thing essentially. It just takes this request, the username and the token, asks the profile service whether this is the authenticated request or not. So the profile service, of course, has information about the user, and the profile service says yes or no. A yes or no response tells the gateway whether it should respect this request or not. If it needs to respect this request, it will direct it to the correct service. Otherwise, it will fail the request. Okay, that's all that the gateway does. And once, of course, it directs it to the correct service and it gets a response, it has to forward that response to the client. What you have done here is decoupled systems. You have taken away the requirement of talking to a user, and after authenticating, sending it to the correct service from the profile service, you move that to a gateway. Another good thing about this is that if you're going to be using some of the messaging protocols that we'll get to once we are at direct messaging, then you have separated out the protocols over here and the protocols over here. Okay. So now that we have our profile service, we are just going to be updating the profile. We are going to be changing the description. We are going to be changing the name maybe, so on and so forth. Images. Do you really want to store images in the same place that the profile service is? There's no hard yes or no, but logically, you would probably want to store the images in a separate service. Because tomorrow, if there's any other service which just needs the images of the user, maybe for machine learning, maybe for just, it just needs the images to send it across. So you could effectively do that by using an image service. Rather, a more sensible scenario is when you just need the details of that person's profile, maybe just the description, or maybe just the age, and you can send it across easily, while the image service is used for heavy computations when you need all images of that user. So the image service is going to be, of course, having a distributed file system in which it's going to be storing all the images. It's also going to be having a database in which you have the profile ID and you have the image ID and you have the URL of the image being stored in this distributed database, right? So these are references. Okay, so first requirement done. Yay! We have taken care of the first requirement. And what do we do next? The second requirement was recommendations. I wouldn't go for that just now, because it's a little complicated to get into. What I would suggest is going for direct messaging, which is chat. So for that, one of the things you can do is you can think about how do I connect from this client to another client, which is over here. So this client wants to talk to this client. Imagine that you just matched with someone and you're going to send a direct message. It means that you're going to be telling the gateway that, hey, I want to send message to user ID X. So instead of the update, it's going to be message to user ID 1 from user ID 2. So this guy is user ID 2 and this person is user ID 1. Now the question is, how do we send a message to this user? There's a lot of people who asked about what is XMPP last time. And if you know about HTTP, which is Hypertext Transfer Protocol, it's mainly a protocol, a way of talking between two machines. And in this way of talking, there's always going to be a client and there's always going to be a server. So a client talks to a server responds to that request. It's never that the server goes to the client and says that, hey, can you give me some data, right? So when you have a client server communication protocol, you cannot have chat. You cannot effectively have chat, because if there's a client and a server, the only way that this user is going to get the messages that are sent to them is to poll the server, is to say every 5 seconds, hey, are there any messages for me? Hey, are there any messages for me? And that is extremely inefficient from the overall app side. So you don't want to poll the server, you want messages to be pushed to you. And if you want them to be pushed to you, there are multiple ways. You can actually do it with HTTP also to some extent, but instead, the better way to do it would be to use a different protocol, a peer-to-peer protocol, where everyone is equal. All right, so there's no client server now. This is a machine, they're peers. And if the server needs to send any message to the client, it can. So one of the protocols actually doing this is XMPP. All right, and one of the client server protocols, of course, is HTTP. So make sure you mention this, because it's pretty important to know how clients and servers talk if there's a chat application, right? So this message is going to also be sent through XMPP probably. So we have discussed how we are going to send the message and get the message, but what's going to happen internally? Internally, one of the things that could happen is, you know, the connections that this person, this XMPP is going to be taking a connection, and that's a WebSocket connection. All right, a lot of this might sound like jargon, so study. Yeah, well, in a system design interview, you're expected to know a few things about this. Instead of WebSocket, you could also simplify and say that, hey, I'm going to be writing a protocol of my own, but it's going to be TCP. Yeah, because you make a connection and you maintain it. So TCP, TCP, happy, happy. Now, with these connections, you can actually talk to the clients. That's good. Who's going to be maintaining the information of these connections as to, with every connection ID, you need to know which user is using this connection, right? So there's a set of connections on the gateway service. Each of these users need to use this connection to be able to talk to other users. You need to find out, where does this user belong? I mean, which connection is that user listening to? And if that is the case, it could be done by the gateway service. But again, I suggest you decouple the system as much as possible. So you take away responsibilities of maintaining connection info from the gateway service by putting that in another service which can handle sessions. So this service is going to be handling sessions in your overall architecture. If you are having direct messaging, this is more than enough, because it's going to be storing connection information, user ID to connection. Right? And with that, what you can do is you can figure out where the other user is stored, I mean, which connection are they using, and send a message to this socket then. So direct messaging is possible. If you do match, things are looking good now. However, of course, the 2 requirements that we had, they have been taken care of. Out of the 4 that we had, 2 of them have been taken care of. The only 2 remaining are noting recommendations, and the second one is, what is the second one? It's recommending suggestions. I mean, recommending people to you. So noting recommendations, let's quickly go over it. Let's say that you have the client, right? It can store information. It's an app. It can store information. Why not have all of that information as to who you're matched with or who you have asked to be matched with stored on the client? Are there any pros? Are there any pros and cons? Yeah. Are there any cons to this thing? Well, one of the cons is that the server should be the source of truth. You should have the server knowing everything, and you can then rebuild on that. I mean, in case a client loses all the information, in case they uninstall their app, the server has all the information. But what kind of information are you losing when you're noting down matches? If you match with someone, send that to the server, say that, hey, I have matched with this person. That's going to be probably sent to the profile service. Maybe it could handle that, or it could be a matcher service, which just keeps a table of user ID to user ID, which means this user has matched with this person. Now, indexes, like we talked about, are going to be put on each user ID over here, right? So, in fact, you can put it on both, but I'll just put it over here, and you can duplicate the records. So A matched with B means B also matched with A, and you can keep it that way. Now, the matcher is going to be checking if you're matched with a particular person. That can tell the session service whether you're authenticated to actually send this message to that person, a direct message. So there will be some communication between the matcher and sessions. So in case there's a message being sent, it's first going to be sent actually to the matcher, which will confirm that yes, you have been validated to send this message. It sends it to the sessions, which then sends the information as to which connection you have to use, and then you can always send it to the right place. Right, so it's a pretty long process. You might find a better way to do it, but in general, this is fine. This looks fine. Okay. So we are talking about noting matches. If we need to note down the matches, the matcher service can note down all the matches that you have. If the app is uninstalled, when it is reinstalled, it will pull out all the matches you have from the matcher, make sure that you can chat with them. Your profile is going to be pulled out of this service, and the only information you are going to lose is the number of people you swiped left or right. Is that critical information? No, because you should get a chance again to swipe a person right or left in case you have already done that earlier. So you're going to get re-recommendations of the same person. So that takes care of requirement number 3. We are storing all information relevant to the number of matches you have had on this matcher service, and all information relevant to who you have swiped left or right inside your cell phone. And in case you uninstall it, too bad, you have to do it again. That's all. Not that big a loss. So 3 requirements taken care of. That's good. The final requirement we are going to be looking into is a little complicated. It's about recommending people to you. And let's see how we can actually put it in this architecture. The biggest problem with recommendation will be to figure out who are the users close to me. So I can figure out quite easily which genders I'm interested in, which age group am I interested in, using just indexes. But when you look at this number of users, you have 1 million active users, you have to, per user, figure out which person is close to me, right? That is the core of all recommendations in this system. So the profile service could have in its database the name of the person and all those things, but they also have the age. That's good. We also need the gender, right? And we also need another thing, which is the location. So based on age, gender, and location, these 3 things, we need to make decisions. Now, a lot of people would probably come to the conclusion that why not put indexes on all 3? Okay, and this is a common misconception. You cannot have multiple indexes. Basically, you cannot have the data sorted in multiple ways in one database table. So if it is sorted by age, and it is sorted by gender, and it is sorted by location, when you're going to be making a query, it's only going to use one of those indexes. Okay, so it might use the gender index. Maybe I am interested in females, so the female category will be picked up by the database. It will be made efficient that only females will be picked up in just one shot, because there's a binary search going on over there. And in that, I'll have to search for people within a particular range. And in that, I'll again have to search for people within a particular location. So it depends on what the database picks up as the single index that you have. But because it depends on the database, because it depends on the database optimizer, query optimizer, it's out of your control, right? Pretty much. So, you can suggest the query optimizer, but what I'm getting to is that you need to optimize on multiple parameters, and you can effectively do it only on just one. So in this case, what happens is you need to use either a NoSQL database like Cassandra, which is really good at querying for these kind of data types. You just replicate the data in multiple places, and depending on the query, you build a table on that query. and then you can have an efficient query. So one of the things about the recommendation database is you could have a distributed database, which is something like Cassandra or Amazon Dynamo. Okay, that's the first solution. The second solution is if a person is not very comfortable moving on to a distributed database, you could use the same concepts kind of on a relational database. And that requires something called sharding, also known by the veterans as horizontal partitioning. Horizontal partitioning means you take some property of a data. Basically, you set ranges in one column, and you direct data to a location based on that range. So a lot of fluff that I just talked about. What about name? Right? All users having their name starting from A to J are going to go to database node number 36. All users having it from K to P are going to database node number 79. Now you see what's happening here? I'm partitioning the data based on its value to different locations. And in this case, what happens is when I'm going to be querying the data, I can easily figure out what's the name of this person. Oh, then it must exist in database number so and so. Right? Partitioning as a concept is really useful. One of the ways that you can partition data is sharding or horizontal partitioning. So I would suggest you have a look at the consistent hashing thing. Anyway, consistent hashing is going to be critical to keeping your servers functioning. So after that, you can also have a look at sharding, which I'll probably take a video on sometime. But that's it. That's what sharding is. You just do horizontal partitioning, and based on your value, you're going to go to a particular node. As usual, what about the single point of failure? What if this node crashes? Are all users from K to P going to fail? I mean, are the requests going to fail? No, you can have a master-slave architecture. So if the master fails, the slave comes up. If the slave fails, then you're happy. No, I mean, the slave failing has a really low probability because both of them have failed at the same time. You can bring up a node in between. So that is sort of how you are going to be doing the horizontal partitioning. Per partition, you can have a master slave or multiple masters and slaves. But then, you'll need to convince your interviewer as to why you're choosing sharding, which is a little complicated versus using a database like Cassandra or Dynamo, which is going to give you all of those features in one shot. Okay, now why am I using sharding? Why am I using Cassandra? I mean, why am I talking about all this? I'm so sorry. The reason I'm doing this is because you need to shard the data based on the location that that person is in. So it doesn't need to be necessarily a city. It could be chunks of that city. You can figure out that, okay, a person within this location is within this chunk. And if it is within this chunk, they are being sharded to a particular node. Okay? Based on that chunk, therefore, you can easily pull out data also. You can pull this data out, all users within that chunk, and then search amongst it within the age and the gender variables. So each of these databases can actually have the age sorted, and you can query on the age. And then finally, you just filter out the genders that the person is not interested in. Okay, so this is the kind of stuff that you could do basically to improve your recommendation engine. Your recommendation engine is going to be simple enough. It's going to be a recommendation service. All it does is it pulls out all relevant people, maybe from the same profile service thing, or it could just be storing the user IDs and the locations, the current location. This current location can be updated every hour, every 2 hours, every 3 hours. Depends on the client. It can push that thing, or the number of pushes it makes doesn't matter. Only after an hour you are going to make an update to the location. And based on this location, you're going to be serving users for that particular user. All right. Okay. If any of this is going, seeming too complicated, it's fine. It may not be the right time to just start off with building systems. but you can get the general gist of what's happening. If you're able to break this system down into pieces, and if you're able to essentially partition and remove single points of failure and figure out how these features are going to be done using interactions with each of these services, then you're doing well. All right, good job. And that's pretty much it. I think that takes care of the second point also of recommending people. You can recommend using this way. That takes care of all 4 points, in fact. And Tinder is one of these services which, in fact, seems quite simple and is, because there's not so much of a news feed that you need to take care of. There's not really a lot of social interactions going on. Like, it's not group messaging, it's just direct messaging. So it's a nice system to start with, I think. It's one of the interesting systems I felt that I should start with. And if you have any suggestions, or if you feel like there was something that we missed out on, definitely leave them in the comments below. I think we are going to have a really fruitful discussion in the comments below after this. And if you have any doubts on this, feel free to ask. I'll try to post as many relevant sources in the description. If you like this video, then you can just hit the like button, and also just subscribe to the channel, because I'll be posting on similar services all the time. So yeah, that also gives me the question as to which service do you guys want to see? Do you want to see Instagram, Twitter? It's up to you guys. I mean, basically just leave a comment, or maybe I'll take a poll. That will be easier. Just make sure that you subscribe so you get a notification for the poll also. Otherwise, I have to ask every time. And I'll see you then next time.